Hello everyone. Thank you for joining this month meetup. We are bringing in Mr. Eric from the Not AI. So this week's meetup, we are discussing about NetsPresso platform, the hardware where AI model optimization. So as we have 2 weeks ago, the first part of the series. So this week, Mr. Eric will introduce about the NetsPresso platform and its benefit. Do keep in tune to our meetup channel. So every month we are bringing a lot of interesting sessions and topic. And also the recording of this is available in our YouTube channel. So we'll be sharing the recording in our meetup channel as well. And you can ask questions during the session to Mr. Eric in the chat. Otherwise, you can also keep the mic muted at all the time. And if you have any questions in the Q&A session, you can unmute yourself and you can ask the question, or you can post the question in the chat thread as well. So enjoy the session. Over to you, Mr. Eric.
Yeah, thank you, Mr. Vidya, to introduce me. Hello, everybody. It's a good day. I'm Eric Hong, a research engineer in Nota AI. Nota AI is a startup based in Seoul, South Korea, and we developed AI model optimization platform to help deep learning model engineers. So let me introduce. So this time in this meetup, I'm going to introduce the NetsPresso. Let me share the screen. Wait a minute. So if we have any questions during the session, during this meetup, don't hesitate. Please don't hesitate to leave a message in the chat so that I can respond to you right away. So let's begin. So in this meetup, I'm gonna introduce the NetsPresso, a platform. It's a platform for hardware-aware AI model optimization. I think somebody is still waiting outside. This chat is okay. So yeah, as Udia has introduced, I have introduced the Nota AI solution of driver monitoring system and intelligent transportation system 2 weeks ago. So this is a two times of series. So this time I'm going to introduce the horizontal solutions of AI, Nota AI. It's a hardware-aware AI model optimization platform. So you can refer this YouTube channel to see the previous, to see what kind of contents was in the previous sessions. So our company is founded in 2015, 7 years ago, and now we are in the stage of Series B, which have cumulative investment funding $22.5 million. And we are based in Seoul, Korea, and our clients and partners are global big tech hardware companies like NVIDIA and ARM and Samsung and LG, so on. And we are our two big investors are LG CNS and Samsung Venture Investment. We are based in Seoul, Korea, and not only is in the office in the South Korea, we have two locations of global presence. And first one is Berlin, Germany, and we have also a branch office in San Jose in the state. So in the two locations in San Jose and Berlin, we have mostly in our sales units are there, and our sales units are there, and most of our engineers and researchers are working in South Korea. Our core competencies are composed of two parts. First one is AI model optimization platform, NetsPresso, which I'm going to explain today, this time. It's an automated software platform, and it's optimized for um, small edge devices. And our second type of core competency is AGA development competency, which is composed of intelligent transportation system and driver monitoring system. So these two vertical industrial solutions were enabled by the output of NetsPresso. So the output of NetsPresso is actually a small AI model, Keras model or TF-Lite model or TensorRT model. AI models they are compressed enough for the small devices to be used with a low power electricity. So if you want to know more contents about these vertical industrial solutions, you can refer the YouTube channel Bluechip. So yeah, so in this session, I'm gonna only introduce this NetsPresso part first for the very first part. So our team, Notel AI, most of our most of our crews are R&D developers and researchers and so on. So I'm one of them. So we are mainly consist of experts in machine learning, embedded systems, and most of us are in computer vision domains. So you can also find our news, our presence in the LinkedIn. So connect to LinkedIn and search Note AI. We see the recent news. Our recent news are mostly uploaded and posted via the LinkedIn. So as you can see here, we have participated in TechCrunch Disrupt 2022, which was held in San Jose in the seat, and we are actively participating different exhibitions and conferences and workshops and online meetups like this. So if you want to know more about us, you can follow our LinkedIn postings. Okay. So this is the main scenario. I'm gonna start from here. Hardware aware. What is hardware aware AMR optimization? So this shows the utility of on-device AI. As you can see, the figure for the humans under the water, in over the air, on the sea, they're all in the car. They're all different environments for humans, but for the machines, in particular, the small machines, they are the same environment, because in terms of power connectivity and network connectivity. So for example, under the water, the devices which should work under the water cannot be connected via the LAN cable for data transfer, and they cannot be connected to the power cable for the electricity. Over the air, the same. In the car, the same. So the machine in terms of machines, these environments are all equivalent. So we make AI models for small AI models for small devices, which are used in this kind of harsh environment for machines. I think somebody's still getting in, so please, yeah. So there are many types of edge devices, so regardless its industrial areas, um, most of our edge devices are now they are getting powerful. The edge devices are getting more powerful, so that small AI models works well. Now they are still near the AI models are getting inside of the edge devices and working individually, disconnected by disconnected to servers. The edge devices, the AI model in the edge device works individually. So there's the need of hardware-aware AI model optimization. Traditionally, AI model researchers developers make AI models in the server side and test it in the server, and the output of generated output of model training is an AI model, and they just put it into pass the AI model into. Actually, AI model is a file, like Keras model is H5, and PyTorch model, TFLite model, TensorRT model. The models were just passed um, to attach it in the small device, and it just do the inference, right? So it means during the training phase, the AI model is not aware of the existence of edge devices, which the AI model will be deployed into. It means the AI model, which is this is a core message, by the way. In the server side, when the AI model is trained, the AI model should know which edge device each will be deployed into, right? So this is the need of hardware-aware AI model optimization. So traditionally, AI model engineers disconnect, disjoint these two server side and edge side, and train in the servers and deploy it in the edge. So the AI model, when it's trained, it does not know about the existence of the edge device. So we want to solve this problem for the AI model to be more optimized for the small device. When I say small device, it's an edge device like Raspberry Pi, Arduino, or just Nano, and so on. So we call it informal term, we call it hardware-aware AI model optimization. For informally, we call it small AI model for small devices. This is our slogan. We make small AI model for small hardware, small devices. So this is what we do. And yeah, thank you for muting. I think I can mute the others. Okay, if you are, yeah, I don't want to be get disturbed. So if you have any questions, please use the chat rather than a mic. So thank you. So what we do, the AI do is making a lightweight deep learning neural network with hardware-aware AI model optimization. So this is challenge. There are a lot of steps in AI model pipelining from the data set to the deploying stage in the edge device. There are many different steps are in the row. So but in most of our courses, most of courses, most of works in the company is done in the model training and prediction this stage. But when it comes to the service for the rear industry areas, we have to consider all of the pipelines from the top to bottom. Desired output determination, targeted identification, model selection, and data set management, and collecting data set, labeling, data cleaning, and feature engineering, and cloud architecting, and they do the model training and evaluation and prediction. You may already know that these three-part training, evaluation, prediction are like just very small part of the very long pipelines. And after that, they have the post post-processing and deployment. And when it comes to the edge device, we have to customize the model for each edge device. You know that TensorRT and TF-Lite models need to different software versions for TensorRT and TF-Lite, and each model should be more. There is still a room for each model to be more optimized into the small devices for each device. So we build the pipeline itself. When you call it NetsPresso, it covers from the top to bottom. It covers all the pipelines, and it's, in particular, we are much more specialized into the customize this part deployment for each device. So for deep learning engineers, complexity matters. Complexity for many different steps to attain the small AI model. Way to go. So we made the NetsPresso to make it much more clean. It's composed of model searcher, model compressor, model launcher. So NetsPresso is actually a family of 3 different submodules: model searcher, compressor, and launcher, and the edge. So if we have different in this different stages, I have different challenges. I think what your place is not a. I think it's not a good signal, right? Yeah. If you are, let me share again. I think there's a technical problem. If you find any disturbance, please help me to keep going this session.
Okay, now try to share.
Yeah. Share screen. Okay, so if you find any disturbance or any interrupt, please jump in and help me to find out the problem. And if you have any inquiries, if you have anything in mind, please leave a chat rather than interrupting in the screen itself. Okay. So there are 3 different parts, and there are 3 different phases in a model AI modeling. If you have a data set, you want to find a small you may want to search a small AI model. If you have a pre-trained model, you are in a different stage. But actually, if you have any pre-trained model, you may want to know how to compress a large model into smaller one. Then you can use the model compressor. So if you have compressed model, if you have small model, and you just want to deploy in a model in the small device, maybe you can use the you can use the runtime engine, and you should use the software code which packs the small AI model that can be work in the small device. So this is an NetsPresso ML pipeline. So this is a brief. Actually, this is a very brief overview of an NetsPresso. The input is a data set and target hardware, and you set a target performance of an NetsPresso. Then output is an optimized AI model. So NetsPresso is composed of model searcher, compressor, and model launcher. And model launcher, output of model launcher is a TF Lite or TensorRT model, and the model are packed into packed with the software, like for a Python code, so that you don't have to worry about the how to deploy the AI model into the small device. So currently, mainly we support object detection task, but recent release of the NetsPresso will cover the classification and segmentations. So we don't do the natural language processing or signal processing yet, but we are only focused on the computer vision models. So our clients are mainly not the individuals. Our clients are most of our clients are business side. So we do the B2 business to business. So we open the NetsPresso in public, where you can visit our website, and you can use all the functions or free with the limited credit. And we sell our solution to the clients of the big tech companies like hardware companies. So not only for the each device, NetsPresso is good for the cloud. So you can see the slide. If you can, we can use the small AI models for small devices, and the small AI model optimized for the small devices can be also used for the cloud to attain a much faster and much accurate result in the cloud. You can see that with the very same the instances in MS Azure, Microsoft Azure, with the NetsPresso, the output on NetsPresso is actually AI model, small AI model, and they can use much more. They can cover much more number of camera channels, 5.3 times more camera channels, and in the lower spec, with the different spec T4 instance in the Azure is much lower spec comparing to the 3100 instance. So even in the small chip instance, the output of NetsPresso is much more faster than the than the than the than the one without the NetsPresso. 2 times, and it can help you for to save the cost for the cloud. So we do our business by providing for the individuals. We provide our solution via the website. You can now we are going to do the hands-on tutorials on the website. So it's for do-it-yourself platform. So it's a lightweight AI model built on automated platform in computer vision and SaaS delivery for the non-SaaS services. But if you are AI engineers, you may know that not all AI solutions can cover all the different AI models and all the different types of hardwares. We cannot cover all the variety, all the different versions. So if you cannot find your device in our NetsPresso, if you are a hardware engineer and you make your own custom hardware and your own runtime engine, then if you cannot find how to do the AI modeling for your device, you can bring your device to us, and our researchers, engineers are going to help you to use our solution for your device, for your customized device. This is our professional service part. So we do it for you. If you have any specific, any different hardwares which are not normal, which are not widely used, we can help you by the professional service. But if you are stick to the NVIDIA Jetson series or Raspberry Pi and so on, which those devices are widely used in global, then you can use it yourself by using our NetsPresso, our solution. So NetsPresso is a composed of, as I referred, NetsPresso is composed of model searcher, compressor, and launcher. And you can see the figure. The input of NetsPresso model searcher is a data set, computer vision data set, no, set of images. And the output of NetsPresso model searcher is an AI model. And model compressor input is a model AI model, and output is a compressed model. And model launcher input is compressed model, a small AI model, and output is package. Pack means a Python code will WHL files, package AI model, and you can just install the AI model into the edge device. Then you can use the edge device for your different use, right? So driver monitoring system and IT systems are two vertical solutions we have. And this part we have handled, we have explained this part in the previous meetup. So we are going to, in this meetup, I'm gonna proceed with this NetsPresso with the hands-on tutorials. So it's a pipeline component. We deliver value by optimizing models with a model searcher and by searching small models. And we provide model compressor, which make larger model into smaller one. And we help the users to deploy small AI model for their different hardwares by providing model launcher. So it's an automatic AI model, AI optimization platform. So the pipeline that builds AI models for small hardware, small target hardware. So NetsPresso automatically searches and trains the optimizes models based on the input dataset searcher, compressor, and test their performance on the model launcher. Let me switch the scene. You visit the NetsPresso. This is the hands-on tutorial, so you can visit netspresso.ai, and this is a website, service website, and you log in, sign up, and put your informations here. Here, create, and log in with your email. They're free for all, so there's no restrictions for using this service. So this is an NetsPresso composed of a model searcher, compressor, and launcher. Okay, let me wait for somebody to create their account for 10 seconds. Yeah, thank you. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so for the step, for the very first step, yeah, yeah, that's true. Yeah, that's true. Yeah, for some time, but it's not always, but for some time, we need to make an ensemble model for increasing the accuracy for some reason. So we need a data set. Okay, so visit this website. I prepared this. I'm gonna share site here. This is the chat disabled. So you can see, yeah, so chat is disabled. So you can see the screen here, the universe.roboflow.com, and use this address to connect to download the data set. use this address, universe.roboflow.com/54321. Yeah, so visit the website and download it, download it to computer and format. There are different label formats. I'm gonna use the Cocoa format and press continue. And wait for seconds, and the data set will download it and come back here. NetsPresso. So in the model searcher, there are samples. I'm gonna load a data set, which is just downloaded from the public. Press upload data set. Then you see the data with this validation. This dataset validator will validate the formats. If the formats of the dataset, labels of the dataset is well formatted for the NetsPresso or not. So if you, depending on the operating system you are using, you press the button and download the dataset validator. I'm using Mac, so let's see settings. So open the dataset validator and see. This is a location. This is a folder locations of the data set I have just downloaded from the web. It's an Ego Hands data set. They're playing in the figure, in the images. The two persons are playing cards, and Ego Hands detects there are four hands here: left hand on my side, and left hand and right hand on my side, and left hand right hand of the opponent. So Ego Hands will detect if the hand is belong to me or the other side. So press the train folder, select the validation folder, and select the test folder, and press the select the dataset format. I'm using Cocoa, and press run. And make a new folder so that the output of validation will be generated in the empty folder which I just created. And wait for seconds. The validator will generate zip files. I wish it will not take so long time. Maybe less than 1 minute, I think. Yeah, it works. Training, test, validation. Each data set are compressed in the zip file, and there are two more informations and data. This file contains the class information of the data set, and the certification refers to it contains the information of hash code. This hash code will be used for the NetsPresso if the data set was get through the NetsPresso validator or not. So let me come back to the NetsPresso. And dataset name, ego hands, and task with object detection and dataset format, label is Cocoa format. And I'm gonna upload the dataset I have just generated with the NetsPresso validator, training, validation, and testing, certification, and class information, data.yaml file. So this is our set, and start upload. By the way, the EcoHands public data set, the number of, how many number? It's 11K, 11,000 training set and 480 validation and 480 testing set. So we wait for the uploading to be completed. So it's done. And with the data set, we create a new project here. Create total number of data set is 12,207 in training, validation, and testing. There are two classes of hands, my side and the others, and the other opponents. See details, hand and hands. So let's create a new project. And quick search, there are advanced search and quick search, but this part is coming soon and to be continued, to be announced later. And now we are going to use the here quick search. Quick search, ego hands, quick search, ego hands. So object detection task and data set, select the data set. And this is the hardware aware part. Before the training begins, we choose different options. NVIDIA Jetson, Raspberry Pi, Intel Xeon, and this ARM virtual hardware will be available soon. This is October, so it will be available at the end of this month. So this is the part. So if our clients bring their own custom device to us, our engineers study the runtime and SDKs of their custom device, and we put it into one by one, in the list of the target device the NetsPresso supports. So ARM virtual hardware is our next generation, and the fifth and sixth and so on. And in this tutorial, we are going to use Raspberry Pi 4B output format, output data type, inference batch size, and target latency. Target latency means in this part we select this is a giving the restriction for NetsPresso to find AI model which latency is less than 500 milliseconds. So for the H device, the point is not rather than the accuracy. It's the point is the speed of inference rather than the accuracy. So in the advanced option, you can select the training epochs, number of epochs, and hyperparameters, and we can even give different options for the data augmentation. So data augmentation is already inside of our NetsPresso model searcher engine, so you don't have to care about I have, like, for example, I have 500 images with labeled. So I think that's just a small number of labeled data set, but it's fine for us because we have this part, data set augmentation. So use this and press next. This recommendation and press which fits your taste, and next. And select the available server and start a project. And yes, it will consume credits, 100 credits for one time using the model searcher. Press confirm. And the quick search echo handler process is doing its work, and it'll be done less than 2 hours, 2 or 3 hours, I think. And after it's done, the processing is done. This is the result. So this meetup is already that we have the time limitations, so it's not good for us for waiting all the training phase. So it's just leave it, and this is completed with the same data set with the same parameters. This is a completed project. Object detection, echo hand, Raspberry Pi, latency objective is a 4 or 5 milliseconds. See, this is a description, and this is a result. And this will show a result of the AI model, which is found by the NetsPresso model searcher. And this hands is there for the opponents, and this hands is my side. And once we obtain equal hands here, result. And once we have AI model, the model will be shown here. I think it's not, I think it's just in part, it's just still working. So after the model searcher is completed, the output model will be generated and will be shown in this models part, model section. So you can upload your own custom model by pressing the upload model part here. And after the output, you can see here, the output of a model, MP model searcher is a model, and this model will be input of the model compressor. So press this model and press any of them and press compress. Now we are in the model compressor. So this is automatic compression. One-click compression may not be the best result, or you can see the advanced compression with the model visualization, the profile of the target device, and I'm going to use this compress model, select the base model, and this will give a compression method in pruning and filter decompositions. We support in the compressor, we support mainly two types of compression method. First one is structured pruning, and second one is filter decomposition. And structured pruning is there are many different structured pruning method in the world, but we picked 3 main pruning method. Just click one and select method. So it will show the profile of the AI model, and you see the numbers here, 6307.67 microseconds is a layer-wise latency. So the layer-wise latency will give a hint. Which layer is the bottleneck for the entire models. I think this is this thing and this thing and this. I think I want to compress these things, right? For example, so press. Let's give like compression ratio for each layer. If it's too hard for you to put one of it, one by one, you can use the recommendation to give printing ratios automatically. So press compress here. So this compression, now we are in this phase. We put AI model, which was generated by the model searcher, and we put it into the same model in the model compressor, and we are waiting for the output of the model compressor, and it will not take that much time, up to 5 minutes. So after the model compressor work is completed, the output is a compressed model. Its extension is TF-Lite, mainly TF-Lite, and we'll put it into the model launcher and the output of packaging model, and we put it in each device. This is a whole pipeline, and we support we provide NetsPresso with the intention for the users to use our horizontal solution. Okay, so we have seen the model searcher for developers, AI model developers. Model searcher is in this part. If our users or clients have the data set from the very beginning, we use the model searcher. If you have your own pre-trained model, you don't have to use a model searcher to have the AI model. You just begin your steps here from here. With your model, you use model compressor, or you just deploy your model directly to the model launcher without using the compressor. So model searcher uses inside of it has a neural architecture search engine. So input is a data set, output is optimized AI model, small AI model. So it supports various search options, and it's hardware aware training. In the training phase, the AI model know which hardware device it will be deployed into. For example, a Raspberry Pi, Arduino, or custom devices. Yeah, so we support easy steps to build models. So they are trade-off, right? Input is a given data set and hardware, and give information of the target device, of target performance of MEP and latency. And output is a optimal model which meets customers' requirements, accuracy first or latency first. There are trade-off like this. This plot shows a trade-off of latency and the accuracy. For example, this shows the MS Coco and target hardware NVIDIA just Nano, and MEP from 0.5 or 0.95% is like this. You see NPN, NPL, NPT, and NPP refers a trade-off, like latency first. If you want this fast AI model, if you want a fast model, you attain like this performance of an MEP, which represents the performance is less than 30%, and or 40%, 50 over 50%, your model will get slower. So this is a trade-off. Yeah, inside of a model searcher, we use a neural architecture search engine. Every AI modeling is actually fundamentally, theoretically, is a neural architecture search. For example, a ResNet, FujiNet, this kind of clean architecture it's searched by the humans, right? actually the neural architecture search is done by researchers, the human engineers. But the neural architecture search, and there's a domain of neural architecture search can be done with the machines. For example, like this. This is the model, and this is all the skip connection layers are here and there, and human engineers cannot find this kind of complex architecture, but machines can do. So this is called neural architecture, automatic neural architecture search engine, and this engine is inside of the model searcher. So it's a hardware aware neural architecture search, and the output of our model. This is an example of multi-real-time people detection on Just Nano. It supports 3 different models with the same device. With a single device, with a single device of Just Nano, its FPS frame per second is 13. So 3 different models are running simultaneously in the Just Nano. It's fast enough and it's very lightweight, so that many different models can run simultaneously in the small, low-powered and low-spec device. By using the model searcher, you can find this kind of optimized model. Yeah, optimize the model and very easily. I think the compressor, the work of compressor is done. So this shows the compression result from here to flops, from here to here. Model size is reduced, and number of trainable parameters are reduced, and number of non-trainable parameters are reduced. You can download the result here, and compressed model needs to be trained. So, okay, let's come back to the model, and this is the compressed model I have just generated. The latency is like this, and you can download it right away and click here. This shows the specs of the compressed model, and yeah. For some reason, the restraining button is disabled, but it's supposed to be able here. Maybe there's some problem in the server side temporarily, but it'll be fixed soon. Yeah, so it's a model compressor, and this is the compressed model, so that you can see the architecture using the Netron. You will see this compressed model, and before the compression, after the compression. You see the before the compression, the model size is 262.9 megabytes, and after the compression is 71.3 megabytes. It's a three times smaller, like this, before and after. Most of the architectures are the same, but the shape of the architecture is the same before and after the compression. But you may find the number of parameters are different right here for example, this patch normalization layer or come to the layers here, they have different, this compressed part has much smaller number of, you can see here, before with the same architecture, with the very same architecture, and this left side is a before the compression and right hand side is after the compression. The number of parameters are different and mainly it's reduced, right? From 28 times 75 is 345. So it's a, but the performance is very similar or like 1 or 2 percent point accuracy drop can be occur, but the accuracy drop can be recovered by the retraining phase. So it's a model searcher and model compressor. And the remaining part is the model launcher and model package. Model launcher is composed of a converter and package. And since we are still under construction, it's a model launcher has some problem in temporarily. It's a beta version, but conceptually, let me explain it just conceptually. The converter converts from some extension of the model into the other. For example, um, Keras model to PyTorch, Onyx model to Tensor, Onyx model to Keras, or Onyx model to the TensorRT or TF Lite, or vice versa. So model launcher in the converter of the model launcher help you for converting this extension of the model and the other extension of the model. And this package will support to cover AI model with the Python wheel or Linux SO file so that the engineers can use AI model which was generated by the NetsPresso and package it with the wheel file and install it in the H device and just to press the run button to use the model. And unfortunately, these two functions are still in working progress, so I cannot show it in this time. This model compressor. And this is a model compressor part. And input of the compressor is AI model, and output is a compressed AI model. And compressor is a ready-to-use compression toolkit. And it supports all CNN architectures, but we don't support SVN or we don't support the RNN architectures. We only support the CNN architectures, but any type of CNN architectures is okay. YOLO or ResNet, VisualNet, AlexNet, and so on. Any type of computer vision models is okay. And model compressor, in the model compressor, we support series of different compressor algorithms, filter decompositions, and structure pruning algorithm. And we both support Onyx and Keras and PyTorch. And this is a bird view of how to use a model compressor. From first, step one, you collect data set. Step one, to train a larger model with the model launcher, model searcher, or you can train by yourself. And you obtain, once you have a large model, you use we use this is old symbol we have. We have another different symbol. I forgot to exchange this, replace this thing. By the way, once we have a larger model, we transfer into a smaller one. This is what compressor do. And after you have the small AI model and deploy it a small device and make decision via the camera and apply to various domains. Before and after. And this is a result table of the model compressor, which shows the model compressor. It works very well for the classification and CIFAR 100 benchmark data set. And object detection task with the Pascal VOC dataset, so on. We have in the research level, this table shows a compressor. It works well for different data sets and different tasks. This is the concept of model launcher. Since I have skipped the tutorials of the model launcher, maybe I have to use a 3 to 5 minutes in this section. So model launcher is located in the very end of the whole pipeline. Input of model launcher is optimized AI model, and output of the model launcher is a production ready package. Build file or Linux SO file covers and packs a small AI model file. So the output of NetsPresso will be sent to the device and come back and see the result like this. In our server room in our company, we have a big server rack, and the server rack, we call it apartment of the devices. We call it apartment of the devices. So in the apartment of device, different devices are installed in the server rack, row and columns. And once we have one type of AI model, we can broadcast the AI model with each devices and see the result simultaneously, and the result will come back to the NetsPresso model searcher engine when the model searcher will search another architecture, and so on by iterating the feedback loop. And in the model launcher, we also have a licensing server to manage the license for the device to prevent the copying of the AI model which are deployed into a small device. So model launcher is composed of packaging, converting, and licensing, and all the functions are tested in the device farm. And if we use a local server, the output of AI model, it's hard for the AI model to be deployed into run FG device directly. But using the model launcher manages the data flow and the type of and the specs of edge devices, so that you can skip this kind of crash. You can just use the edge device smoothly, so that we want to help hardware providers or hardware manufacturers to easily expand their software pools. This is one scenario of using model launcher. This is converting server. Input of converting server is a model. Output is another extension of AI model. And device farm controls data flow and devices and check accuracy and time, and pick one the best option and send it into a packing server. Input of packaging server is an AI model, and output is a field file. Each packs an AI model, and the field file will be installed in each device. And input of the licensing server is serial number, and output is a permission. If the device can use the field file or not. So if the field file is permitted by the licensing server, it gives the inference for the user. This is one typical scenario to use model launcher. So user, model searcher, model launcher, and the model launcher has a device farm and converter server and packaging server and plus one licensing server. Yeah, and all the data flow is a get through with the proxy server model package proxy server. So I'm gonna skip this part because I have explained all the things in the real time. So yeah, we have enough time, but I think I have explained all I have prepared. So if you have any questions so far, please leave a chat or chat disabled. Um, yeah, thank you. I think it's done. So if you have any questions so far, please leave a note or chat. If not, and thank you for participating. I think it's ended than usual. So I'm gonna skip. I'm gonna pass the flag to the host. So
Thank you, Eric. Thank you
yeah,
for the wonderful session. Thank you everyone for joining the today's session, and we are planning to have more sessions like that in coming months. To do keep engaged into our meetup channel. Also, we'll be sharing this recording as well, so you can have the recording of this today's session. So if you have any further question, you can reach the Not AI team as well. They are happy to help and answer your queries. And I would like to thank again Mr. Eric to this wonderful session and sharing about the Not AI and the NetsPresso platform. Thank you again for joining everyone. Looking forward to seeing you again another meetup session like this. Thank you.
thank you for your time. Yeah, thank you for the host, Mr. Udia, for preparing this meetup.
Thank you. Thank you.
Yeah.
Thank you, everyone.